All right. Thanks everybody for coming here today to this webinar. I'm super excited to be here talking about how to architect AI agents with LlamaIndex and technologies from AWS, such as Amazon Titan and Amazon Bedrock. This is a huge topic these days, and probably you are aware of this, but we're going to do like this presentation that's going to be broken down into three parts. We're going to talk about RAG as an architect. We're going to talk about Amazon Bedrock and its foundation models and the support it has for it. And then we're also going to start talking about the LlamaIndex. So this is the agenda for today, right? And I'm going to let the presenters like introduce themselves in a minute, but after this, we're going to start talking about RAG agents and then Redis AI for agents and how Redis fits on this entire architecture. And obviously, we're going to talk about Amazon Bedrock and also orchestration with LlamaIndex. With me today, we have Anthony Prasad from AWS, which is an amazing person and knows tons of AWS, specifically Amazon Bedrock. And he's going to be talking about this in a minute. So Prasad, if you want to introduce yourself for a minute.
Thank you, Ricardo. Pleasure to be here with everyone. I'm Anthony Prasad Devaraj, Senior Partner SA here at AWS. Been with the company for close to 9 years. I still am very much a recovering data engineer, which used to be the first part of my life at Amazon. At the end of the day, the important essence is garbage in, garbage out. No matter how sophisticated your LLM is, no matter how great your application is, if you don't have the right data set and the way you structure your data is actually going to power your Gen AI applications. So with that being said, I'll hand it over to my good friend and peer, Ricardo. Take it away.
Thank you, Prasad. And also we have Laurie, which is the VP of Developer Relations of LlamaIndex. So Laurie.
Hi, everybody. Yeah, so I run developer relations at LlamaIndex. You're going to hear more about what LlamaIndex is and why you should use it in the course of this presentation. As background on me, a long time ago, I was co-founder of NPM Inc. So you may remember me from when I used to talk incessantly about JavaScript. Now I talk incessantly about AI, but the common thread is that I talk incessantly.
That's super cool. I remember that, Larry. So I remember that. Thank you, everybody, for coming here today. And also, we have Ricardo Ferrero that happens to be this person here. So I am the lead developer advocate at Redis, and I've just joined the company. I'm actually coming from AWS. So Prasad and I, we were like co-workers a month ago, actually. That's quite new. And I'm very excited with all the things that Redis has to offer and integration with the other technology. So I'm going to start off like I would like to put everybody on the same page about the understanding about RAG, right? RAG is a common term these days. Like it's definitely one of the most like hot topics in the technology industry, but it is always important for us to kind of make sure that the terms and the understanding of it is the same, right? Whether if you are an expert, whether you were hearing about RAG for the first time. So the building block of RAG architectures is what we call embeddings, right? So when it comes to data, right, this is actually the raw material that RAG architects are going to use to do what it's supposed to do. And Ricardo, what is RAG in the end of the day? RAG is the ability for you to augment request and answer scenario with facts, right? So the way you would create and store those facts in the form of embeddings, right? The retrieval part is actually the process of when you actually are responding to a question that has been sent to a LLM or large language model or a foundation model in the jargon of AWS Bedrock, Amazon Bedrock, it's going to make sure that the process of the answering is going to be as accurate as possible, right? And we call all of this process end-to-end the augmented generation, right? So this is what RAG is all about. If we look at the typical architecture for RAG or architectures, this is usually what we're going to see out there, whether you were implement with Redis or not, whether you implement with Amazon Bedrock or some specific LLMs, right? You're always going to see what we call the usual suspects, right? So the knowledge base is one of them, right? The knowledge base is where you're going to set your context and those facts that were mentioned before, right? And also you're going to have the persona of the user queries, is exactly with the questions that your user or customers are asking to the LLM component, right? And then the component that's going to tie the LLM to the knowledge base and the embedding service is going to be your orchestration framework, to which in this case, we're going to be using the LlamaIndex. And there's a huge reason for you to start developing your agentic RAG with LlamaIndex. So Laura is going to explain a little bit more later. But usually this is what you are going to see when a typical RAG implementation, all right? You're also going to use this component of the embedding service, which is the service that's going to transform data into a set of vectors or embeddings, right? That's going to become your facts, right? And then here is what we are calling the evolution of a RAG architecture. Evolution in a sense of whether you are implementing, regardless of the technology that you are using to implement RAG, you are going to face some problems. Let's call them industry/customer problems that are omnipresent everywhere, right? One of them is, for example, the process of the need for events queue, right? For example, all of this in the end of today is a distributed system that creates a lot of network interaction, right? So let's say there's your website just came live and it became a wide success. So a lot of customers are using the AI agent to ask questions about whatever their business needs are. And then you have to have some component that's going to throttle those interactions so you don't overload your backend systems, right? So this is something that we are fixing and solving with Redis these days. Also, there's the component of a semantic cache, right? Semantic cache is the ability for you to, surprise, surprise, use Redis as a cache, which is the most popular use case for Redis, but with a huge difference, right? And here comes the part we call semantic cache. It's a specialized type of cache that knows how to interpret a question and make sure that even though it's not the same words that are being asked, but if some similar question has been used the same answer, it retrieves from the cache instead of going for it entire to the LLM. And the huge value for this because you're going to save a lot of token interactions for the LLM service. And also the agentic memory, so you can create a more comprehensive context every time you are going to deal with questions. So everything that has been discussed before is considered in the upcoming and forthcoming questions, right? And lastly, we are also have this component called semantic router, which is it is a component where you can use for when you don't want to rely only on one specific LLM that specializes in everything. You can create different LLMs or use different LLMs that has been trained into specific domain models or domain expertises, and then you can route accordingly depending on the context that you are dealing with. So all of this create a more complete and more human-friendly version of RAG architectures, right? And of course, the usual using Redis as a knowledge base to store the facts. Another trend that is probably kind of a very, it's not so common as RAG itself, but it's starting to kind of keep up these days, is the concept of agent supervising. So agent supervising is this ability for you to create a much larger view of one specific agent or multiple agents. So you create a more human-friendly version of the human interactions that your customers are going to use with the agent AI. So again, Redis is going to be using as a persistent layer, and then there's going to be some built-in integration with the agent supervising here. That can be also implemented with LlamaIndex. And lastly, Redis for AI, which is kind of the component that we're using for this new generation of RAG architecture, it has this foundation in this component that we call Redis Query Engine, right? This is something that we've built on top of Redis, or the Redis that you know and love. And then we have this kind of a Redis Query Engine that was originally created to allow Redis to perform JSON document search on it. But when we start adding support for vectorization, it also, the same engine allows this vectorization searches and semantic cache and all the components that we've discussed so far to also work. This is the foundation that actually gives birth to the flexible development tooling that we have available, including integration with LlamaIndex. So there's some very interesting partnerships that we did with LlamaIndex to integrate frameworks and the SDK and the code level, and also the components that we are calling them, if you look the architecture from the architecture perspective, in less than the code perspective, those are the components that we support that are backed by the query engines. And all of this is what we are using to sustain the use cases that you can implement with this architecture, right? So this is the first step for you to understand this new type of approach for us to implement RED architectures. But one very important concept that you have to master to understand this is exactly how the LLMs are implemented and how this integrates with the Redis technology. And for this, I am going to actually invite my friend Prasad, that's going to give you an overview about how Amazon Bedrock fits into this.
Thank you, Ricardo. I would still need your help to share the slides.
Absolutely, no worries, my friend.
We're almost getting there, I swear. But thank you. Let's start with the previous slide. So I just want to spend a moment, help you guys understand why we're having this conversation today. If you think about it, in 2023, a lot of our customers were still doing POCs, right? And a bunch of questions kept coming up. Hey, how do we go from POC to production? What am I supposed to do? How am I supposed to prioritize my projects? Or how can I lower my costs? Stuff like that, while Ricardo is trying to fix the slideshow. But long story short, customers have realized that we were actually able to build production-ready systems. And the reason we were able to do that is because we leveraged Amazon Bedrock in combination with ISV solutions like Redis, right? Ricardo, I think you can just share the slides. I think there's a screen recording delay when you share slides. Like if you go to presenter view or just present slideshow, there might be, it's fine. But hey, what's without a imperfect demo? That's how it is. But having said that, in 2024, we've achieved massive success with our customers. We've seen systems in production. Last year at reInvent, there was a presentation by NASDAQ, which actually involved a fraud detection system that was leveraging a database software solution, and we were able to take that to production. And we also noticed, for example, doctors were able to diagnose the treatment that was supposed to be given to a patient based on historical data. So we created production-grade ready systems in 2024, and now we're taking it to the next step. With that being said, I want to cover a few topics today on Amazon Bedrock and what it is and how we've got here, right? Ricardo, I think you're sharing this wrong slide. Maybe you want to go back a few slides.
Go back and forth.
Yeah, we can see the Bedrock models slide now. No, we got to go the other way. In reverse, I think you're moving forward, Ricardo. Okay. Yes, let's start from here. What are the needs? What is the service itself? I'm going to talk about some of the key features, and we're going to touch upon some of the customers. The only slide that I want you guys to maybe take a photo of is the last slide where we'll share a QR code on everything that I've just talked about. It's a hands-on workshop. It's a 4-hour workshop that lets you actually get started on everything we've talked about. Let's move on to the next slide, please. Yes. Okay. The top 3 questions that we come across from all our customers today. Hey, Anthony, there's so many models out there. What model do I use, right? Where do I get started? Second one, how quickly can I go to production? Now, before this evolution of Gen AI, during my days as a data engineer, I remember when we had spent 6 months to productionalize a click probability model. This model, all it was supposed to do was predict if this ad on Amazon.com was going to get a click or not over the next 7 days. Sounds like a simple ML problem, sure, but then getting data is a problem, right? So that's where we took 6 months to go to production. But today we don't have 6 months time. Last but not the least, Anthony, is my data secure? Is my data only accessible to me? These are the top 3 questions that every customer had. Next slide, please. And to address all these questions is why we launched Amazon Bedrock. What Amazon Bedrock does for you is think of it as a platform that can host multiple LLMs and foundation models, some of which Ricardo just talked about. But think of it as a single API call you are able to leverage the power of all these LLMs. You're able to deploy AI agents. You're able to deploy the entire RAG flow that Ricardo just touched upon, right? Right from retrieval, augmentation, and finally generating your output. Everything can be automated using Bedrock in the console itself, right? And last but not the least, on security. I don't know how many of you guys are familiar with Private Link, but AWS Private Link is a service that ensures your data coming from outside the internet into your AWS VPC is absolutely secure. And Bedrock is Private Link enabled by default. So you don't have to worry about any data security concerns. Let's move on, Ricardo. All right, just to summarize, with Bedrock, you can pick a bunch of models, LLMs and foundation models you can play with. You can customize your model as well. So let's say you say, hey, Anthony, I want to tweak a few parameters to adhere to my use case. Yes, you can absolutely tweak that and customize that. And guess what? The copy is only in your control. Unless you specify permissions to your IAM roles and policies, the other people in the room don't get access to your model. The next one is you can integrate seamlessly with other native AWS services like Redshift. For example, if you have a data warehousing request, you can store data in Redshift and then you can feed it into Amazon Bedrock. You are not going to be charged for additional access to the service. Bedrock will only charge you for the number of tokens you consume per minute to run your LLM. Last but not the least, we talked about the security and governance. If your data lies in Europe, we have all the local governing policies adhering to our standards. And we are available in most regions across the world. I will have a slide talking about that as well. Next, please. All right, so this slide is very, very outdated, clearly outdated, and it will be outdated next week as well. As those of you who are following reInvent, we launched something known as Amazon Nova, which was our very own foundation model as well. It was based on or inspired from the work we did with Amazon.com shopping experience. If you guys have tried our Rufus, and then Alexa, of course, the conversational style AI hardware that has existed for years, where you could place orders or even requests for things that you had purchased in the past. So Amazon Nova, I know it's not mentioned on the slide, but I will share the link in the chat in a moment when I get through. But the point of this slide is you have a ton of options. We work with some of the top grade LLM providers like Anthropic's of the world, Cohere's, Meta, Mistral AI, and Stability AI. All these guys have their LLMs offered to us through the Bedrock console. So that's the key takeaway of this slide. Next one, please. And I want to focus a little bit on Claude in particular, right? Because Anthropic's Claude is actually one of our best performing models in terms of the sophistication it brings to the table, in terms of the cost benefit it has, in terms of the ability to scale as well. So, and the option I want to give to the customers here is we have something for everyone. Let's say you want to start small, you don't have a very complex use case, you don't require that level of intelligence and sophistication, but you're focused on speed and cost alone. Then you're better off with Claude 3 Haiku because it's the fastest performance and the lowest cost. But you get a compromise on the ability of the LLM itself. If you want something somewhere in between all these worlds, the second best performing one is Claude 3 Opus, which gives you intelligence, which gives you the speed, and it also gives you the cost benefits. But our most powerful one till date is Claude 3.5 Sonnet. So if you really want to build a sophisticated, intelligent application, we recommend going there. And again, you bear the costs, but we have cost mechanisms to optimize your workload as well. I'll talk about that in a little bit. Let's move on. Okay. Again, this is one of the most sought after features. I'm glad we launched this a few months ago. And the reason we did this is, you have a ton of models out there, right? So let's say you say, Anthony, how do I know which model performs better? Which model performs better than the other one? Well, guess what? Bedrock introduced something known as a model evaluation report. And we have two options here. So if you follow my theme so far, we are going to have humans. We're not going to replace humans. We're going to enable and help humans build faster, better GenAI applications. So we have two options here, automatic or human evaluation. If you pick automatic, you will let Bedrock decide based on the metrics and the KPI. I know the slide might be a little convoluted, but there's a ton of metrics and there's custom metrics you can define, which will specify what the performance means for the impact of the end output. Or if you pick human evaluation method, you can specify your email alias or your team's email alias, and you get a report saying, hey, user, here's how the performance metrics looks. Model B performs better than Model A. If you give a thumbs up, it kicks back the workflow in your Bedrock console. It's that easy. Next one, please. I want to spend a little bit of time on this one, right? So going back to Ricardo's conversation on RAG, right? Like, how do you structure data? How do you store your embeddings, right? Once you've figured out all that, right? The next question is, how do I improve the accuracy of my model response, right? Because obviously, if you're a customer that cares about the data itself, the quality of data itself, there's a combination of techniques we want to introduce to you to enable you to provide high quality data results for your end users. Prompt engineering, as Ricardo said, it's a simple, standard, well-known technique. You provide prompts, the LLM gives you a response, you narrow down the search results, and then you get a better response, right? Then the other one is the RAG workflow. I'm not going to spend time on RAG because Ricardo talked about it. But then the other two approaches I want to talk about is fine-tuning and pre-training. Now, if you're a data scientist, and if you know what good looks like from your model, if you know the false positives, if you know the false negatives, you can define that within your S3 bucket, for example. And then you let the model skip records, for example, that are not in line with what you're expecting. And then you can only consume the data that is required for your model. So that's one way of fine-tuning. Pre-training is for people who don't know what their data looks like. Let's say you come in and you say, Anthony, I got this raw data dump. I don't know what to do with it. I haven't checked it out. Then you can opt for continued pre-training. Because then what you do is you allow Bedrock to go through the data and give you what is in the bucket, S3 bucket itself. So it'll break it down into buckets and tell you this is exactly what your data looks like, right? And then it can also generate mock data sets. So if you're a data scientist, you want to productionize a model, you want to go from POC to production, you need to test your end results. You need to test the use cases. You need to test every possible edge case. We can generate mock data sets with continued pre-training. That's one of the features I would highly recommend you guys to check it out. Now, if you want to get a perfect result, I would say play around with a combination of all these 4 techniques. Again, it depends on the cost you want to incur. It depends on the time you want to consume. Let's move on, Ricardo. All right, this is something that we introduced very recently, which is known as Bedrock's prompt flow. So if, for those who are not familiar with this, it's like a drag and drop experience, right? So you have a bunch of icons there. And let's say you built your data source, which is starting from a legacy system, or it's an S3, and then you pick a combination of models that you want to use. You can do this through the console itself. So you can select options through a drop and drag Dropbox bar. That's how easy it is. So that's why we created prompt flow. And it also helps with collaboration within the team as well, right? So think of it as a playground for people to test it out. We can move on, Ricardo. And this is how it looks like, right? It's that easy. Drag and drop interface, versioning is also enabled. So if you make changes to one workflow, you can revert back to the previous version. And it really has changed the lives of developers, and it's made it very, very user-friendly. Next one, please. All right, here I want to spend a little bit of time, right? Bedrock has something within the console itself, a feature, an optional feature known as knowledge base. And I want to take a step back to help you guys understand what knowledge base means. So let's say, a pharmaceutical use case where the doctor is trying to figure out what is the right patient diagnosis for patient XYZ based on 5 years worth of clinical trial data. Now, question, how does your LLM know what your patient went through? No idea. It's domain knowledge. And that domain knowledge is going to be input to your knowledge base. So what knowledge base is actually doing is it's providing domain knowledge to LLM in educating the LLM about what exactly we're looking for in this patient based on the clinical trials. So it's as good as an input to your Bedrock, LLM. And this is something that we're working with partners like Redis. Redis is one of the few ISVs who is actually present as a vector database offering on the Bedrock console. We are slowly trying to incorporate Redis as a knowledge base input, where the Redis database itself can be an input to knowledge base. So then we're trying to eliminate the need for moving data outside your database, exporting to S3, and so on. So we're working on that with Redis team as we go on. But again, in this use case, the user fires a query, looks for data within the domain. That is fed as an input to your knowledge base. You like the data or not, you're looking for more details, you provide the prompts. And then in this example, we've selected a combination of these 4 models, not just one. And then eventually you get to your final answer. And that's how knowledge bases work. Let's move on. All right, there we are. Redis Enterprise Cloud is actually available on your Bedrock console. We have been available for over a year now. We were launched at last reInvent. We've optimized and launched even further innovations with Redis Vector Database. There's something known as LLM RAG evaluation that we launched recently at reInvent. So if you're a Redis customer, you have your data in Redis Cloud as vectors, then you can definitely check it out. I would highly recommend you to explore this offering on the console. Next slide, please. All right, we already talked about fine-tuning and pre-training. I would highly recommend you guys to go through that with the Bedrock console. The step-by-step tutorial that I'll share at the end will also provide you steps to do so. Let's move on, Ricardo. All right, I do want to say that since I spent a lot of time on Claude 3, we have fine-tuning specifically for Claude 3 models. And Amazon Bedrock is the only fully managed service that provides the ability to fine-tune Claude models. So that's something that you guys, if you're working on, I would highly recommend checking it out because the feature exists for you out of the box. Next slide, please. All right, the conversation of the day, right? We talked about AI agents and, how does Bedrock fit into this piece, right? Now, no solution can be built just by one service. It's a combination of services. Like Ricardo said, you have to use Redis as a vector store for the reasons mentioned. And then what next? So in this way, you can define Bedrock agents to execute on your behalf. So what does that mean? Every time there is an API call made to look for a specific service, you don't have to write separate code facets to get that API to work as expected and pull the data, for example, or send it back. You can orchestrate that to the Bedrock agents. It's as simple as providing basic instructions through English. Select your foundation model. If you remember the previous slide, four LLMs you've selected, select all of them. Provide those instructions in the Bedrock console. The next one, what am I doing? Break it down into steps. Look for this API if I'm checking for, is this asset in stock or not? I'm just giving a retail example. Let's say you're a retail company, you're trying to find out if this product exists or is in inventory or not. Provide that orchestration piece in the instructions. The next one, select the right data sources. Where is my model going to look for this data? Is it in an S3 bucket? Is it in the legacy store? Select that relevant data source. And last but not the least, is for those of you who are familiar with the AWS reference icons, that's a Lambda function, right? So we're given an example here is, let's say you have all the things in place and you want your Lambda function to specifically execute on this piece of code with this API call. Provide those instructions as well. This entire thing can be automated. So it's a one-time human intervention. We're not taking the human out of the loop. The second thing is we also have a chain of thought tracing enabled, which allows you to diagnose and troubleshoot the issues at the layer. For those of you who are familiar with CloudFormation templates, we're not going to give irrelevant error codes. I was one of them who kept complaining. I'm sure Ricardo can attest to that. Some of the error codes were gibberish and didn't really provide you exact details. But the chain of thought tracing actually gives you specifically where the problem is. Next slide, please. All right. For those of you who are familiar with the EC2 consumption pricing, similarly, we have on demand. For those of you who are not aware of what workload it is, how many tokens you're going to consume, we recommend starting it on demand. If you are familiar with your workloads and if you're familiar with the number of tokens you're going to consume per minute, I would recommend provisioning with ahead of advance because you don't want your application to ever go down. And then we also introduced batch inference recently because there are companies who actually want to process the data in chunks or micro batches. That is one way to do it via Bedrock. Next slide, please. All right, we also introduced cross-region inferencing. What that means is if you're a European client, you're running your LLMs within data residing in Europe, we probably don't have enough resources to run your models, then we're going to go to another region, fetch the resources temporarily, and help you run your workloads. And that is why we introduced cross-region inferencing. We don't have extra charges for you on that account. Let's move on. All right, as we continue to grow, these are the regions that we exist in today. We also exist in GovCloud. If you're a GovCloud customer, we highly recommend checking that page. We also are in adherence to all the HIPAA and GDPR compliance across the globe. And we're continuing to expand as we go on. Next slide, please. All right, we're almost there to the end. I know I've had to rush through the glitches we've had in the technical presentation, but here we are. Adidas, they built a Bedrock knowledge-based repository with documents or wikis that would enable software developers to get started when they onboard to Adidas. For example, there were a ton of irrelevant, outdated documents created by people who had left the company years ago, scrapped them all out, and provided only the relevant links to their engineers to get started. That's why they use Bedrock. Next slide, please. Booking.com, for example, they would figure out Anthony's travel patterns, and they would send me suggestions and travel itinerary lists and say, hey, Anthony, maybe you should be exploring Hawaii this season, summer. We're past summer anyways. But, those are the kind of things that Booking.com figured out. They had a lot of customer data, and they were able to create personalized recommendations for every customer of theirs. Next slide, please. NASDAQ, this is the example I talked about. They presented a reInvent ago, and they built an anti-financial crime and surveillance application using Bedrock. But for those who are concerned, how do I get to know more about these? These are public references. There are customer reference architectures, GitHub codes available on the Bedrock customer testimonial page. All you need to do is go to the Bedrock customer testimonial page and look for these customers. Your customer might be one of these. And maybe you can draw inspiration from what we've already done, so you don't have to start from scratch. Last but not the least, the next slide, please, Ricardo. This is a slide I want you guys to take a photo of if you can. This QR code actually helps you get started with Bedrock. Everything I've talked about in the last 15 minutes. If you want a hands-on feel, step-by-step tutorial process, go through it, provide us feedback. You can reach out to me or us. I will share these details post this session. With that being said, I will hand it over to the folks on the other end. Thank you, Ricardo.
Thank you, Prasad. I appreciated that. So let's continue with our presentation. So I'm going to hand it over to our friend Laurie, which is going to present about LlamaIndex, which is the glue that connects everything. So Laurie.
Thank you. All right, whoops, I shared the wrong screen. We practiced this a million times, and yet I clicked the wrong button. There we go. That's the right screen. Okay, so thanks, Anthony. So far, we've heard about RAG and what it is and how to use Redis to build it and how services from AWS fit into the equation. Now let's take a closer look at LlamaIndex, which is, as Ricardo said, the glue layer that brings this stuff together. Let's start with what LlamaIndex is. At our core, we are an open source framework. We are available in Python or TypeScript. And what we do is we help you build world-class generative AI applications. Specifically, we focus on RAG and making it work well and building agents on top of your RAG pipeline to provide really great results. I'll go into how we do that in a bit. But in the service of the goal of making RAG work well, we have a paid service called LlamaParse. LlamaParse parses your documents like PDFs, Word documents, PowerPoint, spreadsheets, stuff like that, and converts them into a format more easily understood by LLMs. This turns out to be a critical feature of any LLM-based application. Making your data easy to understand is a superpower that leads to better apps. If you're an enterprise, we also have Llama Cloud. This is a turnkey service that lets you connect your document source at one end, for instance, an S3 bucket, and we take care of parsing it, indexing it, storing it in Redis, for instance, and give you an API at the other end, which you can then use with the rest of LlamaIndex to quickly and easily build your Gen AI applications. Llama Cloud takes care of the hosting, the scaling, the security, and helps you get to market faster. But a good question is, why should I use LlamaIndex? In fact, why should I use a framework at all? The answer is that we will help you go faster. We have thoroughly explored the space of building generative AI applications, so we've got built-ins and abstractions in place that will help you skip boilerplate and avoid early pitfalls in Gen AI development. You also get a lot of best practices for free. We will help you go from prototype to production with your agentic applications. Let's talk a little bit about some of those built-ins so you can understand the value that we're providing here, because they're really useful for getting agentic RAG apps going. A really simple one is the router query engine. This allows you to provide your agent with multiple data sources and have it intelligently route user requests to the most appropriate source. For instance, if you have multiple specialized RAG databases about different topics, or if you have tools that provide document summaries instead of RAG, it can detect when a user is requesting a summary instead of asking specific questions about the document. The sub-question query engine is another agentic construct. This one is focused on answering complicated questions by splitting them into several simpler questions. It then asks the LLM to answer each of those simpler questions, and once it has the answers, the LLM takes those answers and summarizes them into a single coherent answer to the complex question. Those two built-ins are agentic, but not really full agents. But we have full agents built and ready to go in the framework as well. In these ones, you give them a goal and some tools, and they solve the problem that you give them. They exist on a spectrum of complexity. So some require fewer LLM calls and therefore less time and money, and some require more. So you have to make trade-offs for your application. The simplest one that we offer is the React agent. React, in this case, is not the web framework. It means reasoning plus action. This is a simple pattern that simply looks at the current state of the world and tries to figure out what the next action might be to get closer to the goal. It then takes that action, usually by using a tool. For instance, and that tool might be query this RAG database, or it might be make an API call. And it either gathers more data or it changes something about the world. It stays in a loop trying to get closer to its goal until it either achieves that goal or it gives up. It's simple, but it can be very effective. The next step up in terms of complexity is the structured planning agent. In this agent, instead of trying to get to the goal one step at a time, it first constructs a step-by-step plan, where each step depends on one or more of the previous steps, in what's called a DAG, or directed acyclic graph. You can think of DAG as basically a flowchart, a bunch of boxes connected by arrows going from your starting point to your goal. It follows the flowchart, and every few steps, it observes the world to see if things are going according to plan. If not, it can replan a new DAG to try and solve the problem. That ability, called self-reflection, is a key feature of true agents. Getting even more complex is language agent tree search. This is one of several tree-based approaches to agent reasoning. Instead of generating a single linear plan like a DAG, LLaps produces a group of potential next steps. And then from each of those next steps, it predicts what the state of the world would be. And then it produces another set of next steps from each of those states. It repeats that process until it has this tree of possible steps and states. It then looks at all of the leaf states, the furthest away, and looks for one that is closest to the goal. It then picks that one, collapses the tree, and follows the steps that go down to that particular leaf. If it's not yet reached the goal, it can then repeat the process, creating a new tree until it does. The built-ins that I just described to you are super powerful, but you'll still want to instill your own flavor and encode your own processes into your agents. And that is where workflows come in LlamaIndex. Workflows are a powerful event-driven abstraction that lets you create agents from scratch if you want to, or use our built-in agents in combination with your own agents, and even create multi-agent systems where multiple agents cooperate to solve a problem. Users of LlamaIndex tell us that they really love workflows, and they love the event-based approach and find them a superior solution to graph-based approaches that you might find in other frameworks. Workflows let you create loops, branches, retries, and they have built-in state management, and they allow you to take existing workflows and extend them simply by subclassing them. Observability is a first-class feature of workflows, and they come with a built-in visualizer. This is an example of the built-in visualizer in action. This is a simple agentic workflow. In this one, you can see that the start event kicks off the flow, and the existence of a start event triggers whatever function is marked as handling start events. in this case, the answer query function. Answer query tries to answer the question contained in the start event. It could do that by using one of the built-in agents that we discussed earlier. And then it performs self-reflection and judges whether the answer is good enough. If the answer is good enough, it generates a stop event and the workflow completes. If it can't answer the question, it generates a failed event, and that triggers the improve query function, which tries to come up with a better, more detailed question. That generates a query event, which loops us back to answer query, and the process starts again. But this is a pretty simple flow. A much more complex flow that we've built that's about to become a built-in in LlamaIndex itself is the multi-agent concierge. We've found this pattern very useful for people building support assistants or customer service bots or sales assistants. What it allows you to do is to create multiple agents, each of which is specialized in answering a specific kind of question or taking a specific kind of action, and it allows you to combine them into a single system with an orchestrator agent, which is the thing that talks to the user. The orchestrator, based on its conversation with the user, decides which agent is best to answer the question, and it passes the user back and forth between agents as necessary. We've expanded this pattern to allow human approval if the agent is going to take some important action. In our example, it's a financial services bot, which will let you log in and check your balance, but it requires approval before it will do something irreversible like transfer money. You can check out how all of this works at the repo link on this slide. Now, I said that one of the great things about LlamaIndex is that we help you go from prototype to production, and that is where Llama Deploy comes in. This is a framework that can take workflows built in LlamaIndex and automatically turn them into microservices. Each workflow can be scaled and managed independently with built-in retries and other features you need to make a distributed system work well. Llama Deploy works by spinning up a control plane which manages state between workflows and acts as an orchestrator. It manages a message bus which the agentic microservices communicate with, passing messages back and forth between agents. We are eager to see what people build with Llama Deploy, and you can check it out at the GitHub repo in this link. So that's the lightning tour of LlamaIndex and the things that it can do for you and how it lets you build complex, powerful agentic systems. So now let's pass it back to Ricardo, who will show us a demo of some of these pieces in action.
Thank you, Laurie. Appreciate your comprehensive explanation about LlamaIndex. So let's resume our presentation. So right now, what I'm going to do is what we call put everything together, right? So I think that's a perfect time for us to like take that deep breath and say, wow, that was a spin, right? Like a lots of information about Amazon Bedrock, amazingly presented by Anthony Prasad, and lots of cool information about how the framework LlamaIndex works, also amazingly presented by Laurie. So I think this is all interesting, but nothing replaces that experience of seeing everything together in a real demo. So that's what I'm going to do right now. So Laurie, Anthony, and I, we've worked together to create this demo, which is essentially a chatbot that uses all these ingredients that we have discussed so far. So it uses Amazon Bedrock as the LLM, right? Specifically A120M Labs for the foundation model. And then we're constructing this agent using LlamaIndex. So you get to see the code, and I'm going to explain how it works. So what the code does is we'll upload a PDF document about this, about this car, Chevy Colorado, right? It's actually outdated, it's 2022, so, but it doesn't matter for the sake of what we are going to present here today. And then this agent, this bot, is going to allow us to ask questions about this PDF, and then we're going to see all the components like working together. So I'm going to actually switch my screen here to the notebook, and don't worry, because in the end of the presentation, we're going to make this notebook, the code sample that holds this notebook available for you, so if you can try yourself if you want it. But as you can see here, this architecture is essentially the materialization of what we have discussed so far. So we're going to create this ingestion pipeline using LlamaIndex, right? I'm going to explain the code in a minute. But as you can see here, this red icons here, Redis is being used throughout the entire architecture as this kind of a glue, right? There's two types of glue in this architecture, so bear with me. The first one, it is the runtime glue. So as the messages and the embeddings and the orchestration executes in runtime, Redis is taking care of making sure that all the components, right, the messages are flowing through, right? So that's the first type of glue. The second type of glue is LlamaIndex, but is more in a code level. So this is what you're going to use to tie everything together. So the flow is we're going to upload this to Llama Cloud, and then we're going to process this using this ingestion pipeline. We're going to programmatically create, and then it's going to create a set of embeddings that in turn is going to be stored at Redis, and then our agent is going to use those embeddings to enrich the questions that are the answers that are being provided along with the LLM, and then this is what the user is going to receive, right? Which is the typical workflow for agents. But later in the demo, we're going to also show how the semantic cache works, so you can get to see it about a question being asked and a similar question being also asked, and the delay of how much it takes to respond to the question is going to be much, much faster, right? So in this notebook, right, I've already executed a set of the steps, the installation of the dependencies, because, I mean, it's very trivial. The creation of the Docker container that executes Redis. This is actually very interesting for you to know, because in this notebook, you can actually spin up very quickly a new Redis container with Redis stacks that contains all the components that required for this architecture. So right now the container is running. If you are going to try yourself this notebook, mind that you're going to have to provide two API keys. The first one is for LlamaIndex, right? For Llama Cloud, you create an account there. You can create an account for free, and then you create an API key for yourself, and you're going to open this env.json file where you're going to set your API key there. So that's your first API key. The second one is, surprise, surprise, from AWS. So in order for you to interact with the Amazon Bedrock as a service, you have to provide an API key, and that's important, an API key that is associated with an account that has direct access rights to Amazon Bedrock, right? So this is the heads up number one, the heads up number two, and this is more like a Amazon Bedrock thing. Not only by default, when you create an account with AWS, not all foundation modules are enabled by default. They're 100% available for you to use, but they're simply not enabled. So you have to, in the AWS console, you have to manually request access to these modules for you to use, and then voila, all of them will be available to you, right? So keep that in mind. And in the AWS documentation, everything is fully described. So if you're in doubt, you can always go there. This is the document that we're going to use. So this is the part of the notebook that downloads this PDF here locally. It is already downloaded. And then the last step that I've already executed is this. So this is the first step for you to understand about how LlamaIndex works as a framework. So what we have done here is using the built-in constructs from Llama to parse the PDF documents and create what we call documents, right? Which is like a series or list of chunks or regions of the documents. So each one of those documents represent a portion of the PDF document. So they're all available here in this component called documents. So what we're going to start doing together, and that's the exciting part, right? It is the construction of our index at Redis that is going to store, and obviously, as the name implies, is going to index all those embeddings, right? So the first thing you got to do, there's these two constructs that you have to be aware of. And as you can see, it all uses the LlamaIndex API and SDK. The first one, you have to instantiate an embedding model, right? So there's a bunch of, this is as an abstract class in Python. So you have different implementations of embedding models, one of them being Bedrock embedding, right? Which in this case, we're going to use Amazon Titan. And then the second one, you are going to actually define the schema at Redis, right? Where you are going to dictate like a different information about the fields that are going to be associated with this index, and more importantly, the type of vector that we're going to use. Like, so for example, in this case, we are using a flat vector with 1536 dimensions, right? And then the algorithm that we're going to use to calculate the distance metric, which is how close the embedding is to the question that is being asked, is going to be the algorithm called cuisine, right? So I'm going to execute this, and this is going to be the prerequisite for us to start implementing this, right? So this is the pipeline. Let me execute before I forget. this is the pipeline that uses LlamaIndex for us to create. So I'm going to skip the import part, right? And then basically, as you can see here, it's a very elegant API that allows you to construct this injection pipeline. So it's very, at least for my taste as a developer, is very clear to me. So you are creating a new ingestion pipeline where you are providing almost as a constructor. It's actually not almost as a constructor. This is a constructor in Python language for what is going to be the transformations, which is an array of transformations. You can have set a lot of them. What's going to be the doc store or document store? Because as you store your embeddings at Redis, which is going to be your facts, you optionally can use Redis to also store your documents. So, oh, Ricardo, why am I going to do this? Because guess what? You can allow now multi types of searches. You can search embeddings and vectors, and you can search the actual document, the full text search for whatever is in the PDF document. So obviously this is an optional step, but it is always a good idea for you to kind of use the same data store for all of them. And as similarly, this is going to be what the vector store they're going to use. And then optionally, you can also use Redis in this case for the cache, right? So Ricardo, why cache? Because in runtime, when LlamaIndex does what it's supposed to do, which is the orchestration parts, which is the communication between the layers, there has been a lot of like multi-stage in between, let's call state, that the framework has to materialize and periodically flush to maintain the consistency of the execution. So this is what we call the ingestion cache, right? And the document strategies is basically how the documents are going to be created. Like if there's one existing, we can up insert them, which is instead of create a new one with a new version, just update what's the existing one. And then here's the interesting part, Link. I'm going to actually bring up Redis Insight. For those of you that never heard about Redis Insight, this is a UI that Redis provides for free for you to actually interact with your Redis database. And there's a bunch of powerful features here, but right now, as you can see here, there's a brand new container running Redis, so there's absolutely no keys stored. So what I'm going to do, I'm going to click here on this execution of the pipeline. So we're going to provide the list of documents that has been chunked by LlamaIndex, and then we're going to execute in this pipeline that we've just defined here. So what we're going to notice here is that a set of embeddings are going to be created, right? So this are the vectors that represents the embeddings created. And if you go back to Redis Insight, you are going to actually see all those, let's call chunks. Actually, this is actually the proper term that actually is a chunk, is a portion of your document that is currently state in a hash at vector, right? And you can also see the vector. Obviously, you're not going to be able to actually see this as a form of expression here, but this is actually the vectorization representation of that chunk, right? So this is actually a good practice. A lot of people ask, Ricardo, do I have to create multiple chunks for a specific one document or maybe one huge chunk? I mean, you can. It's more about you shouldn't. Like, it's better if you can like break it down into smaller chunks. This going to your searches and is going to perform faster and more accurately, right? So it's mostly a trade-off between performance and storage complexity, right? You want a huge single line on your Redis or you want multiple ones. So this is more like in the side of advanced practices for you to understand. Now, just recap what we have so far. We have Redis up and running. Redis is already containing all the chunks from your PDF document. So everything is already here along with some of the there's a hash here that also store the references, all the chunks as a document, not as a vector. So we have everything we need to start working with our agent, right? So what we're going to do now is actually start the creation of the agent. So this is the building block that you're going to use. First of all, you have to instantiate an LLM, right? So just like the model that we used before, there's different implementations of LLM supported by LlamaIndex. One of them is Bedrock. So in this case, we are using AI21 Labs. And then we're also using instantiate and chat storage and chat memory. Remember chat memory, so we can keep the context of the conversation ongoing so the LLM doesn't forget what have been discussed before. So this is what we call chat memory. And the chat storage, as the name implies, is going to be where we're going to store our chat. And then with that done, this is the creation of the document itself. So we're creating this function called build doc agent. We're going to provide a document as a parameter, and this is going to be the creation of the agent. I'm going to run through the entire code. You can do this on your own time when you see the sample, right? Let's actually try this out. So I'm going to provide the very first document of that array of chunks that we've created so we can instantiate the agent itself. So it's here, and a doc summary. So if we look to the doc summary, so you can understand, like we provide the description here, provide information about the specs and the attributes of Chev Colorado, right? So it basically is explaining you what is the nature of that document. So now let's start using the agent, right? So we have here a set of questions that are related to the very own nature of the document. So the first one is, what is the seating capacity of the vehicle, right? So if we execute this part, this is the agent already interacting with the LLM, and it's being augmented with facts from the PDF. So in this case, the extended cab has 2 seats, and the crew cab has 5 seats. So this is information that is coming from the PDF. So what is the towing capacity, right? This is another question. So if we execute this, we're going to have the LLM correctly responding that it is 3,500 pounds of for the towing capacity, right? This is another information. If you do like a Command F or Control F on the PDF document, you're going to see this information there, right? And then you can always check the history of the chat so far. So all the questions and answers that has been in this interaction between the human and the machine is always stored on our chat. And just to wrap up, let's talk about the semantic caching, right? I'm going to create one here. And as you can see here, semantic cache is another construct or building block that is supported natively at LlamaIndex. So yet another reason for you to start using LlamaIndex in your implementations. And then what we're doing here is basically in the caching and distributed system word, we call this cache aside pattern, right? So what is cache aside is when you start first investigating if the backend system has the information you wanted, and if it doesn't, you basically go to the backend, provides the answer, and cache it, right? So the next time you go it, you can basically use the cache for this, right? This is all good and stuff, but the main problem of the nature of LLMs is that you don't want to provide an answer just for the sake of responding faster if the answer is incorrect, right? So for example, I'm going to execute here this question: how many doors the truck have, right? So the answer here, I mean, it's currently answer here. Okay, doesn't matter. The point that really matters is that it took 7 seconds to execute this. Now, if we execute the same question again, like how many doors does the truck have, and how many passenger doors the truck have, you're going to see that the same answer is going to be provided. Is the wrong answer? Don't matter about this. Probably something's going on with the backend system here. But the point is, the very own question was associated with the previous one. So if you execute continuously this, now it's hitting the cache instead of going to the LLM. So in the real world, what we're going to avoid is this, like a very huge delay to go into the LLM, because again, it is a distributed system, right? So this is for you to know, understand what's going to be like the idea of the semantic cache, right? And then as you go to this notebook yourself, don't forget to kind of stop the container that is running Docker, right? Because you created one in the beginning of the notebook. I highly encourage you to actually try this notebook yourself. And with that said, let's wrap up what we have said so far. So if you want to create RAG architectures and make this RAG entire implementation and execution to be fast, Redis is the component that you can use for this, right? This is our bread and butter. That's what we do best, like how making things fast, right? And Amazon Bedrock is this amazing piece of architecture that provides you with a different foundation models. And as Prasad presented in the beginning, right, it has a complete integration, the set of features that is going to be very handy when you are implementing solutions like this. And as the glue for the developers to create your own orchestrations, both at the development level and the production level, LlamaIndex is the component that ties everything together. So as I promised, you can try this demo yourself. I would highly encourage you to take a screenshot of this barcode, If you scan this barcode, it's going to bring you exactly to the GitHub repository that has that notebook, so we can try the demo yourself. Hopefully, the semantic cache part is going to work for you and not have the glitch that I've had here. And this is more like a personal request. If you have some time after this webinar, please scan this barcode and give us your feedback how we did go today, right? So we provide you a lot of information. I know that's kind of hard to digest, but your feedback is very important for us to understand what we can improve, what we can do better, and also to kind of share your experiences with us as well. So with that said, thank you on behalf of all my friends, Anthony, Prasad, Laurie, your guys are all amazing, and I'm looking forward to see you back in another webinar very soon.
Thank you. Cheers, guys.